Okay, now we're in my backyard. This is called backyard astronomy using a smart telescope. So here's a smart telescope, here's a smart girl, and we got a table. So basically, the first thing she has to do is what we talked about in the last video, is get the tablet, the icon for Dwarf Lab 2 up and working, connect the telescope to it, and then as a general rule, first thing you do is look for north. So basically you can use a compass, you can, on the sea star, you actually do what they call a dance. You go around twice so it finds what is north from its plating system. But north is up here somewhere. Sun comes up over there, or over here, the moon and sun. Usually comes up over there, so that would be more or less east. Okay? So east, that's more or less west. The sun's going to go down there. Therefore, over here is north. So up here somewhere is going to be the North Star. So that's important. So you point the telescope, any telescope, to start with at the North Star. Okay? And then you tell it what you want it to do. In some of them you have to calibrate it. The sea star you have to do the leveling dance first, you have to do the calibration for the compass and so on, and then you have to find more or less where the North Star is. Now, you'll find that these guys here will only go so far. Anyway, they will not make a 360 degree rotation. There's a stop. So in telescopes, the other telescopes that have wires, it's one of the things you have to be concerned about. They teach that in astronomy. You don't want your wires getting tangled up. And they will. So sometimes you'll have a USB here on a wire. So it could theoretically tangle them. So but basically you have to know what the stop is here and the stop there. In other words, it will not get 360 degrees. So you kind of have to decide when and where your stuff is in the sky. So you plan that like now for tonight. Okay? What time I want, what I want to look at, where it will be in the sky, and I have to know not only the sky, in my backyard, where it's going to be. And then you have to know what we call astronomical time. Astronomical time is a little bit different than regular time. So we go by twilight. Twilight is when it's on the horizon, 6 degrees, 12 degrees, 18 degrees below the horizon is when we get to what we call nautical or astronomical twilight. Astronomical twilight is 18 degrees below. That's when night starts. So as a general rule, you probably you need to find out for this day when astronomical twilight is, and then not get ready to do photography, astrophotography, until after that. Okay. So turn it a little bit, see if you can. Actually, the way it's locked up, I'm sorry, we can't turn it. We can when it's turned on. With electronics. So then, as I said, now, if we want the Milky Way, she will use this here. Okay, this is a wide angle. When we want to look for the Owl Nebula, she will switch to the telephoto. So all the high-powered deep sky will be done by the telephoto lens and so on. So the other thing is your button to turn it on. Here's a button to turn it on, and it will have lights there to tell you the battery. So these kind of devices now are totally different than the regular telescope. In other words, when I sit up here tonight, for example, I can take the tablet, go inside the house and sit on the couch and tell it what to do. And no, she didn't learn it, but our other young lady that was here actually learned how to program it. You can say, okay, the best thing now is, let's say at 10 o'clock, take 10 minutes of cigar nebula. And then after that, take 10 minutes of the owl, cigar galaxy. 10 minutes of that. And then afterwards, take 10 minutes of the whirlpool. And I'll be sitting in the house. Or these hardcore astronomy people who are really into high-power astrophotography, they'll go to bed. And then they'll wake up in the morning and all that will be on these scopes. So, what these scopes do is the world of that we've learned from drones and other devices in photography and video. We're going to take one picture. You can take up to 999 pictures with this. I think 999 pictures. The reason being is that they're not all going to be good. So then you stack these up. So you get 999 pictures when you get up in the morning, and then you'll have to go over that night for work. Then you start taking all these pictures and you put them through software. It's going to stack them. Then the software is going to get rid of all the bad ones and make you one good one. Okay. So now is where you have to learn a whole lot of photography. Because in photography, in astronomy, they do not use the normal photographs. They don't use JPEG. They use what we call FITS, F-I-T-S, okay? So it's a fit dot, whatever, so it'd be owl nebula dot FITS, F-I-T-S. The thing the FITS has got is all this information, the metadata that you need. What the elevation is, what the azimuth is, the coordinates are on the ground. It'll have all of that so that you tie into somebody else, they will know where that was taken so their picture can be meshed into yours. Okay? So you're going to have to start learning in astrophotography, photography at the next step, which is electronic photography. So. Okay.